So again, take out your highlighter. This is on right before example 3, so this is on page 433. So sometimes we have certain quantities we want to measure that have a very large range of values. And some examples of that are earthquakes with the Richter scale, the pH scale, and the decibel scale. They all have such a large range of numbers that we use a logarithmic scale to break it down. And probably the one that you're most familiar with is the magnitude of an earthquake. So here's the formula for the magnitude of an earthquake on a Richter scale. We've got S is the intensity of a standard earthquake, and I is the intensity of the earthquake that you're measuring. And this scale is called the Richter scale, and what it means is that each time you go up by 1, it's 10 times more intense. So they're using an example here that an earthquake that was in Japan, of an earthquake of magnitude 9, if you compare that to an earthquake with a magnitude of 7, it would be 100 times more intense because it goes up by 2. So we're going to find out that when we're comparing earthquakes, we can sort of do a shortcut. We can sort of see how much difference is there between them. So if I had an earthquake that was to the power a magnitude of 7.3, and I was comparing that to a magnitude of 5.1, what difference is there between 7.3 and 5.1? It's going up 2.2. And so if we look at what 10 to the power of 2.2 is, we could say that this earthquake is 10 to the power 2.2, 158 times more intense. Now, if you had this question on an exam with earthquakes and you understood how earthquake magnitudes work, that every increase of 1 was 10 times more, you could just use this type of ratio to solve for it. We are going to show why the formula works and how you could use the formula for it as well in example 3 here. So we'll write out our formula that our magnitude is equal to log of the intensity over a standard. And in part A it says we have the most intense earthquake ever at a 9.5. So the magnitude is 9.5. And question A says calculate the intensity. So we want to solve for the intensity. We want to get that by itself. And it says in terms of a standard earthquake, which means that the variable S, we don't have a number for that, but we're going to solve for I, and our answer is going to have an S in it. So whenever something says in terms of, that means that that variable or that symbol will be in your answer. So when something says in terms of X, your answer will have X in the answer. So how do we solve for I? Well, where is I? The variable I is inside the logarithm. So we have to go through our steps. How do we solve for something inside a logarithm? Spent that review the other day. We had 4 steps to solving X inside a logarithm. The most important step was the second one, which was changing it to exponential form, right? Changed from log form by using the definition to exponential form. Our first step was to write it as a single logarithm. Can you see that this one is already a single logarithm? Step 1's done for us. So we can go right to the most important step and say, let's change this to its exponential form. What's the base? The exponent? And the answer is I over s. So if we wanted to get I by itself, we'd have to multiply both sides by and that tells us the intensity in terms of s. In other words, what this is saying is that earthquake in Chile was 10 to the 9.5 times more than what the standard comparison is, sort of what things are like right now. That's a lot. It's a lot more intense. Now in part B, in the example beside it tells us that Haiti's earthquake was 7. And if we want to compare the intensity of the Chile one compared to the intensity of the Haiti one, does it make sense that the Chile one's going to be more intense because it's a bigger number? So if we want to know how much bigger it is, we can take, I'm going to use a little c for intensity of Chile and an h for the intensity of Haiti. Does it make sense that if we divide them, we'll be able to compare how much bigger the one is than the other? Now the intensity of Chile we already figured out was 10 to the 9.5 standard times the standard level. Without doing all of this work on the left for Haiti, can you tell me what Haiti's is going to be? 10 to the 7 times s. And when you divide those two, what's going to happen to those s's? And so that shortcut that I showed you before, when you divide, what do you do with it? What exponent law do you use when you divide with the same basis? Subtract. So we can see that this one from 7 to 9.5 goes up 2.5. So it's going to be 10 to the power of 2.5 times more intense. 316.2 times more intense than the Haiti earthquake. Give your answer to the nearest whole number. Well, I'll erase that too. 316 times more intense. So again, you're given a formula. You have to know what the things in the formula stand for, how to plug numbers in there, and then it's just using the same things that we've been doing all along, solving for things in logs, solving for things in exponents. How do we work through those things and how do we get our answer? As far as practice from this one, got 4, 5, 9, 10, and 11.